Hello everyone. Today we're going to be looking at the third part of trigonometric integrals. We're going to be integrating powers of tangent x. Let's go ahead and get started with tangent x to the first power. So there's a few ways to do this. You can do it in different ways, but what I'm going to do is I'm going to write this as sine x over cosine x. And then I will be using the u substitution here. So u equals cosine x. From here I get du as negative sine x dx, right? But I don't have negative sine x, but I can arrange it. Sine x dx is going to be negative du. Okay? So from here I'm getting, since I have cosine x at the bottom, and it makes sense to call that u in this case. If you call u equals sine x, then you're not going to get the du because cosine x will be in the denominator. That's why I picked cosine x. So I can just go ahead and substitute everything, and this is going to give me negative du over u. And that is going to equal negative ln value of u plus c. Now we know that u is equal to cosine x, so we're going to just go ahead and call that, back substitute, and we'll be done with our integral. So the integral of tangent x dx is going to equal negative ln cosine x plus c. Okay, this is an important integral. I wanted to start with the first power because we're going to be using this in other integrals as well. So let's go ahead and proceed to the next level. The next problem is going to be the integral of tangent squared x. Okay, for this one, we're not going to use u substitution. We're going to use a different method here. Definitely, there are other ways to do this, but I'm just going to follow this particular method. Okay, so what I'm going to do is, before we get into this problem, let me go ahead and talk about a couple facts here. First of all, the integral of secant squared x dx is equal to tangent x plus c, because the derivative of tangent is secant squared, as you know, right? They're inverse operations. So what it means is that if I can get a secant squared inside an integral, that would be nice. And what's the relationship between secant squared and tangent squared? Well, secant squared can be written as 1 plus tangent squared, okay? This is really good because now I can go ahead and manipulate this equation and then integrate from there. So what I'm going to do is I'm going to be adding 1 and then subtracting it. So this is going to give me something nice because I can now separate them. And as you know, 1 plus tangent squared is going to equal secant squared. So this is going to be the integral of secant squared x dx. And as you know, 1 is very easy to integrate. That's just going to be x. And then plus c, we can put it at the end. Okay. Now, what is the integral of secant squared? We just said that it's tangent x. So let's go ahead and write it. This is going to be tangent x. Let me go ahead and leave some room for the original. So basically, then our integral tangent squared x dx is going to equal, the integral of secant squared is tangent x minus x plus c. All right, so this is very important. We're going to be using this in other problems as well. So let's go ahead and make sure we save it for future. Okay, awesome. So let's continue to the next one. The next one is going to be tangent cubed x. So we're kind of increasing the powers of tangent here. Now this time we do have a tangent cubed. Now, when you have a tangent cubed, again, you can do this problem in different ways, but this is the method I'm going to be using. So I'm going to separate, and a lot of times we use the same method with sine and cosine, right? If you have an odd power of cosine, you separate one of them so that you can save it for du, and then the rest becomes a perfect square, which you can, write in a different way. For example, if you have cosine squared, then you can write it as 1 minus sine squared using the Pythagorean identity. Okay, so that's why with odd powers, we always tend to separate one of them so that we can manipulate the equation better. So what am I going to do then? Well, we're going to write this as tangent squared x times tangent x, right? Okay, cool. Now, we're not going to use u substitution here. Rather, we're going to use the relationship between secant squared and tangent squared. So since secant squared can be written as 1 plus tangent squared, This means tangent squared can be written as secant squared x minus 1. Okay, so they're very closely related, which is cool because now I can substitute secant squared minus 1. But what is so good about it, I'll tell you now. Let me write the tangent x first, and then I'm going to multiply it by secant squared x minus 1. Okay, awesome. Now I'm going to distribute. Let's go ahead and distribute here. We'll be getting tangent x secant squared x dx, and then I can just go ahead and separate them, minus tangent x dx. And didn't I tell you we're going to need the integral of tangent x in other integrals, and it just came up. Okay, cool. What about the first integral though? How do we integrate this? Yes, now we do have a tangent x and its derivative, right? What does that tell you? It tells you to use the u substitution. Absolutely right. So this is going to be u, and this is going to be du. And what is the integral of u du? Well, it's just going to be u squared over 2 plus c. So we can just go ahead and integrate this very easily from this point on. This is going to be u squared over u plus c. And then the integral of tangent x, you will remember, it was negative ln cosine x. But since we already have a negative sign, we can just go ahead and put a positive sign there and write it as ln of cosine x plus c is already there, so I can just go ahead and put it at the end. Now, what is u? I'm going to back substitute. U is tangent x. So now we're going to be getting the integral of tangent cube x dx being equal to tangent squared x over 2 plus ln cosine x plus c. And this is going to be the integral of tangent cubed x. Okay? So with the cubic or with odd powers, again, we separate one of them and then go from there. Sometimes you can use u substitution directly. Sometimes you have to manipulate a little bit using trigonometric identities, but that's the general idea. Okay? All right. Now let's go ahead and take a look at the next problem. And you can guess what the next problem is going to look like. It is going to be tangent x to the 4th power. Okay? So we're going to be integrating the 4th power here. So let's go ahead and do that. So I will be using what here, right? You might be thinking, this is even power. And again, go back to sine and cosine integrals. You can look at the previous videos about them, right? We've done sine, cosine separately, and then we did their products. And we covered all the cases. So that should be good. Now, we're going to use a similar approach here, but it's not exactly the same thing. First of all, tangent to the 4th power can be written as tangent squared squared. But instead of writing it as tangent squared squared, I'm just going to write it slightly differently, which is the same thing basically. So I'm going to be writing it as tangent squared x multiplied by tangent squared x dx. Awesome. Now, why did I write this instead of writing it as something squared? Because I want to leave one of the tangent squares alone, and the other one I want to manipulate. Okay? Why am I doing that? You'll see in a little bit why we're doing this. It'll make more sense when I do it. Okay, a lot of times like, why are we doing it this way, right? And then you see, oh yeah, this is why we do it. Okay, so now, and what happens if I do tangent squared squared? Then I have to replace tangent squared with something, and then when I square it, I'll be getting powers of secant, which we're going to cover in another video, and it'll just be different, right? So I want to stick to tangent as much as possible. That's why I'm separating these two things that way. Okay? So what am I going to do then? Well, remember again, secant squared can be written as 1 plus tangent squared. Therefore, tangent squared can always be written as secant squared x minus 1. Okay, that's going to be our identity. Which one should I do? I'll do the second one. Okay, so I will be replacing tangent squared with secant squared x minus 1. And this is going to do wonders, okay? Awesome. Now, what are we going to do next? Well, distribute, right? There's pretty much nothing else we can do here. And distribution is a good thing because this is going to be awesome. Okay, you'll see in a little bit. Let's go ahead and distribute. So from here, we get tangent squared x multiplied by secant squared x dx. Now we can separate them. Minus, when I multiply tangent squared by 1, it's going to give me what? Minus tangent squared. And we know how to integrate that, right? Remember, 2 problems ago, we integrated tangent squared. So you do know how to handle integral of tangent squared. That's why we go in this order. First the tangent, then the square and the cube, and then to the fourth power. Awesome. Okay, great. So now let's see what we can do with this, right? Well, another thing to remember would be what? The integral of secant squared x dx is tangent x, right? Okay, great. Now what does this do for us? Well, I do have secant squared x dx here, which means this is easily integrable, right? If you have something easily integrable, then you should always think about u substitution. Why? Because you have the derivative of something already in the equation, right? Or in the expression. Well, here's the next step. So that's going to be du, right? So this is going to be my du. Okay, fine. This is du. But do I have u or some power of u or something that looks like u? Yes, I do, because if u equals tangent x, then this is going to work. Look at this. If u equals tangent x, then du would be secant squared x dx. How do you find du? By differentiating, right? And the derivative of tangent is secant squared. Awesome. Then from here, I'm getting something like u squared du, which can be written as u cubed over 3 plus c. Awesome. Then I can just go ahead and integrate this expression as u cubed over 3, where u equals tangent x, and the integral of tangent squared x I already know from another expression. Then let's go ahead and put it all together, and that's going to give us what? And what was the integral of tangent squared x dx? If you remember, it was tangent x minus x plus c. Okay? Awesome. So I can put the constant here. Doesn't really matter. We're just going to have one constant at the end. Okay? So let's go ahead and put this together, and let's see what we get from here for the integral of tangent x to the fourth power. So it's going to look like this then. I have the integral of tangent x to the fourth power dx, and then it's going to be, the first part is going to come from here, right? And that is going to be u cubed over 3, which is tangent cubed x over 3. The second part is going to come with a minus sign. Be careful about that. So I'm going to put that expression in parentheses, and always put the constant at the end. Plus minus c doesn't really matter because c is constant anyways. Okay, so then if we simplify this one more time, we're going to be getting tangent x to the fourth power is going to equal tangent cubed x over 3 minus tangent x plus c. And that's going to be the highest power that we go to in this video. Okay? I hope you enjoyed the video. I hope this was helpful. Thank you for watching. Please comment, like, and subscribe. I'll see you in the next video. And until then, take care. Bye-bye.